Hello, welcome back to Sushi Live Noding. Today I will be talking about geometry nodes and dig deeper into its attributes, etc. So this is one good documentation from Blender Foundations. So basically, yeah, with geometry nodes, you are working with points and you're kind of doing instancing of objects. And on top of that, you have all these attributes that you can work with, like position, radius, rotation, scale, ID, etc., and including custom attributes that we will one day try to cover. I like to use geometry nodes always with something like SVerchok or animation nodes, because SVerchok have lots and lots of libraries to generate points. So let's say we have this default cube. Let's get rid of everything else. I'm using Blender 2.93, and say with SVerchok you want to generate a donut. So start with a donut. So we have these torus that we can scale, etc. So this is the default cube. Let's just hide it. So far, what I've done with geometry nodes is to randomly distribute the points. For example, let's save this very quickly. So this is SVgeo. Always save your blend, and let's go to geometry nodes, and while selecting the donuts, create new. So there are two ways to generate points. The first one is to point distribute. So I've done this a couple of times. This one will simply distribute points randomly. You can also use Poisson these, which will create like a space around it, but let's just use random for now. You can randomize the seed. What's interesting, when you randomize the seed, the points is actually kind of shifted. And then after we do that, we can use point instance and simply drag and drop our instance object. Okay, whenever I use the Poisson, my Blender started to slow down. I don't know why. Maybe maybe there's like a memory leaking. So anyway, we've done this a couple of times. The point instance we can understand. The randomize, if we use the latest 2.93, however, the interesting thing here is we can actually we can click on the attribute and we get this drop down menu. So we can see there are actually already a couple of built-in attributes or attributes that's being generated on the fly, such as this ID. I believe we got the ID because we are using point distribute. There's also rotations. We use rotations a lot of time, right? This is to randomize the rotations. We can use float or vector. There's also things like positions that we can randomize. Okay, this is interesting, right? Suddenly, with the position, if we replace or recreate it, suddenly we are recreating the box and everything collapses into one, because we are simply giving it like a new position for everything. So it's collapsing, become just random positions. You can, however, use it with add. So it will keep the box positions while pushing it a little bit in random directions. So this is probably what you want. So now we still have the torus. If we randomize the seed, you can actually see the box kind of moving. So let's try to do something else. Radius is actually interesting. Let's try attribute randomize and use radius. See, I think radius works with it doesn't work with the scale of the object. It works with the point volume somehow. Yeah, maybe you should use scale. No, it doesn't work. I have a feeling that we can use like point scale. Let's use point scale beforehand. Or put this over there. So we are scaling scaling the point using the radius. So this actually works. And this will pipe down into the object scaling, and also if you are using point to volume, it's gonna take the radius. Okay, still I think this is still like a work in progress, that's why. So other than using scattered point distributions, we can actually just use the geometry, which is very interesting in itself. With the geometry, however, you have a completely different setup that it doesn't always work with all the attributes. You still kind of arrange the object. So if we skip everything, there you go. Now it's actually using the actual original mesh. So let's do a point scale, however. Oops, sorry. Oh, my computer became really slow. Instead of using attribute, let's use vector and scale it down. So we have a cube, and now it's actually following the mesh. So we don't actually need full mesh with polygon face, we just need the points. So it suddenly become like the smallest, the most important of computer graphic. It's a points position in 3D space. So if we have Suzanne here, and I'm just gonna generate Suzanne using SVerchok. We can use this Suzanne to scatter our boxes, or use the Suzanne as instance. So this is Suzanne, name is beta. I can drag and drop it there. So now we have Suzanne head, of course. The torus itself might be too high resolutions, but you don't actually need to use the torus. You can just use like something like maybe like a circle, and you don't need to have everything else. You just plug in the vertices. There. So we have Suzanne. What's that? So by default, with just the point position, the instance will have appearance basically facing like just exactly like the original master instance. But you will sometimes want to play around with the rotations. So we'll check if we have point rotations and align rotation to vector. This is align rotation to vector is what's interesting for me. So suddenly Suzanne head is changing its orientations. You can try to get it kind of facing the way you want it to be. I believe we can try yeah, I think this is we can try using the vector like position. Okay, yeah. Okay, that's exactly what I want basically. And so we are aligning the rotations based on the positional axis. So this is, so suddenly we have control little bit of control of Susan head. You can actually rotate it using point rotations and try which axis is actually doing it. Okay, so we have this. We can rotate it 180 degrees, and now we have unlimited ways because we suddenly have more control over the orientation of each points. And remember, this instance objects is actually real objects as well with Blender 2.93. That's why my computer is a little bit heavy. Each one of them can easily be remeshed, for example. So this object is real if you go under this geometry modifier and simply remesh it. Yeah, okay. I'm afraid it's gonna crash my computer. No, see, it works. Let's so far we are using circle. You can use anything, including vector P. So any points generator, and you suddenly have full control. So I do most of the work here. I mean, in SVerchok, I'm just scattering or generating points and also the instance objects. While inside geometry nodes, you really have full control over the point position, point rotation, point scaling, which is like the transformations of object instance. So this can get quite complicated as well. You can actually do everything in SVerchok, and at some point, if we stick to this thing, attributes and custom attributes, you basically can generate a custom attribute for each point, and you can just pass it into geometry nodes, let it handle and process everything, and then maybe even push it into the shaders to do the rendering of the instance based on whatever custom attribute we provided with. Right. So vector P field is just like a grid of points. We can also use spiral. So this is everything that animation nodes also offer. So this is maybe how you create like a spirally thing. This generates a lot of objects, however. Be careful. Okay, now it's a little bit better, more interesting. This is why I keep saying I keep using SVerchok, because currently geometry nodes doesn't offer you much. You can use other methods to generate the geometry. Any geometry will work. Okay, now we have this. There's actually a way to get the normal of the points. Sometimes it appears. I don't know, I haven't used, this is using the position. So it says the normal. No, it doesn't use the normal in this case, because I think the normal only comes if you use the point distribute. But it should work if you use a vector math. Maybe try not to rotate it. Or I need to select the right pivot. Maybe. There you go. It's pivoting. No, it's not following the normal, but it's possible using. Maybe if we use the attribute vector math and just subtract position with its position and call it the normal. We can use normal here. Oh, actually, maybe not position minus its position. Maybe this should be a vector. Yeah, I think it might be what I want. more or less, I think. But anyway, it's a the idea is to get the normal. Maybe at some point we can just pass in the vector normal from SVerchok as a custom attribute and then let geometry nodes read it. So this is yeah, basically one idea here. You can try yourself. So you just basically with geometry nodes you are working with objects and instancing, right? I already said it many times. So all you worry about is just the points, position, rotation, orientations, and the scaling. So that's pretty much what it is. As simple as that, it's actually you can get really complicated. I like the drop down, it's really helpful. So you can quickly make something like this and remesh it and maybe print it out. It's really fast. So it's very, very useful for that. But I'm really into animation, so I want to use geometry nodes with animations at some point. And of course we can already animate things like this. And the way we do it, if you want, I'm just gonna show you a quick one. This will it will auto translate the rotations. A quick way is simply create a value and then over here just hash frame. This is becoming your time and you can multiply the time. It's gonna if you want to bake this animation, you just export it as Alembic. However, it's going to be like a mesh. I know a trick to turn it back into object animations. At some point, I will show you using SVerchok. So maybe that's probably for the next video. So yeah, give it a try, this method. So you can use the point distribute, attribute randomize differently. You can use this point distribute. I think point distribute will give you the ID and then the normal of each points, while the one that comes from the points, geometry points itself, will have a different attributes. But give it a try anyway. So this one giving the normal, sort of. And if you like this point instance to be outside on the modifier, just plug this object, the orange color object, as attribute outside here. So anytime you want to make changes, like for example, you have this cone, and then you have this object, which is just a container, you just replace it with the cone, for example. Just drag and drop it there. It will work. And you can have collection, of course, multiple objects, etc. And that's going to be something else to talk about when we are dealing with things like ID and material, and how you want to randomize the material based on the index, etc. You can use collections. So these objects, if we select collections, there, we are using our objects and then placing it on the mesh that's auto-generated in SVerchok. There. So it's really just like particles and instancing, but it's a kind of static. Even just this is already really quite powerful. Circle, icosphere, vector p field. all these generators that you can use right away. Okay, so yeah, that should basically cover the basic ideas of geometry nodes, and what if you are starting to get into all these attributes. So each attribute, or sometimes it's also called properties, contain a value, whether it's like a value of vector or radius float. Sometimes the material index is integer, so you can assign different material using procedural way. So that's starting to get this in mind, because this is only like getting started with geometry nodes and 293. It's not even there yet. Once you get into like custom properties, or if you are using like animation nodes to transfer the attributes and values, it's gonna get really exciting. There's a demo by Bradley Animations. If you go to his channel, he talks about these animation nodes and where you can transfer object data value properties into each and every points. So yeah, exciting, really cool. This is actually on top of the usual vertex color and vertex groups. So this is also will work, and dynamic paints of Blender also will work. Everything will work with geometry nodes. All right. So thanks again for tuning in, and I'll see you next time. Thank you. Bye.